In part 1 we looked at solving equations involving two unknowns. We achieved this by taking two equations containing the same unknowns and simplifying using both elimination and substitution methods. Now we will look at the additional complication involved when three unknowns come into play. Problem 1 shows three equations featuring three common unknowns labelled x, y and z. To start off, I need to pick an unknown to eliminate. I'm going to choose x. So let's take equation 2 and equation 3. We could choose any two combinations for elimination, but for this problem I've opted for these two. To eliminate x, subtract 2 from 3. X minus x removes x. Y minus y equals plus 2y, while minus 2z minus z is minus 3z. Equation 4 is going to be useful later for further eliminations. We need a second combination, so taking equation 1 and 2 gives us a second elimination option. Subtracting 2 from 1 will again remove x. X minus x removes x. 2y minus y equals plus 3y, while 4z minus z is 3z, and this gives equation 5. So now for a second round of elimination. Take equation 4 and equation 5. This time, by adding them, z can be eliminated. This forms equation 6. And in finding y, 5y equaling 15 means y is 3. So next we could go back to equations 4 and 5, plug in y and work out z. But I want to show how to eliminate, so I'm going to continue down the elimination route for this example. To find z, we can plug y back into equations 1, 2 and 3. Then move y over to the other side. So equations 1, 2 and 3 are simplified and now look like this. Let's pick two equations for further elimination. In this case, equations 1 and 2. So subtract 2 from 1 to eliminate x. Deducting 2 from 1 forms equation 7. So from equation 7, 3z equals 12. So z equals 4. Now finally, x can be found. So from equation 3, x equals 2 times z, which means x is 8. So to summarise problem 1, x equals 8, y is 3 and z is 4. So taking equations 1, 2 and 3, the equations should be solvable when adding in the calculated unknowns, and in this case, by following each through, everything checks out. I'm going to show one more problem involving fractions. This one's a little bit more complicated. Here, we again have three equations featuring three common unknowns. I need to simplify the two fraction equations in order to start eliminating. So let's start with equation 1. First, I multiply both sides by 4.5. Now I can eliminate from both sides. 4.5 over 12 is cancelled by multiplying 4.5 and vice versa. The equation will not quite work out right now until we do something to the left-hand side. The fraction can be flipped on its head by moving z to the bottom of the fraction and multiplying by 1. The rebalanced equation should then equal 12 when we know all unknowns. 4.5 can be moved across. So multiply by 4.5 becomes 12 over 4.5. We can now simplify the fraction to the right, but we need to simplify a little further. So divide by z becomes multiply by z, and reworking gives equation 4. let's hold on to this equation for the moment. It is going to be useful later when we start eliminating though. We still need to simplify equation 2. Let's start by multiplying both sides by 18. Then eliminate as before. This is starting to look similar to the method used on the previous equation. 4z and 1 move under the fraction and are multiplied to rebalance. 18 moves across. Then simplification. Z is moved across to get rid of the final fraction and realign to form equation 5. So now we have equations 3, 4 and 5 to work with, which should make the elimination process easier. We now have all the information needed to begin the elimination process. So taking equations 3 and 4 first, y can be eliminated by subtracting 4 from 3. And this gives us equation 6, which no longer includes y. The second elimination uses equation 4 and equation 5. So this time I'm going to add the equations to remove y. And the result is equation 7. We can take equations 6 and 7 and eliminate x or z. I'm going to try x, but either will do. To eliminate x, it must be equal across equations 6 and 7. Currently it is not, so we need to form equation 8. So let's multiply each equation 6 variable by 4. So now let's eliminate, and we take equation 8 and equation 7. Let's add them to remove x. 4x is removed by adding negative 4x. We can now find z. And dividing 156 by 26 gives z equaling 6. Equations 6, 7 or 8 could be used to find x. I'm going to select 6, but any of the others will do. As we now know, z can multiply out and move to the other side of the equation. We can therefore say x equals 5. Any of the equations will give us y, as it is the only remaining unknown. Equation 3, for instance, filling in the blanks, followed by reworking, tells us y equals 11. So now we have all three unknowns worked out. Let's do a sense check just to round up. So we have found x equals 5, y is 11, and z is 6. So plugging in equations 1, 2 and 3 and replacing with the 3 worked out unknowns, all calculations work out.